422, Stirling Single. Just 2 driving wheels. That's all you get. Patrick Stirling designed the 422 for the Great Northern Railway in 1870, and the signature feature was a single pair of driving wheels measuring 8 feet 1 inch in diameter, taller than most men. The idea was counterintuitive. Fewer driving wheels meant less adhesion, but Stirling believed a massive wheel reduced slippage and provided smoother, high-speed running. He was right. The Stirling Singles hauled express passenger trains between London and York at speeds reaching 85 miles per hour with lighter loads. During the 1895 race to the north, locomotive number 775 covered the 82 miles from Grantham to York in just 76 minutes, averaging nearly 65 miles per hour. 53 were built at Doncaster Works between 1870 and 1895. The early engines weighed about 85,000 pounds, later ones around 109,000 pounds. Boiler pressure started at 140 pounds per square inch and eventually rose to 170 pounds per square inch. Stirling was so committed to his singles that he refused to allow double-heading on the GNR for years, insisting one engine should always handle one train. The design became obsolete when heavier bogie coaches demanded more adhesion than 2 wheels could provide. Evat's Atlantics replaced them from 1898. Number 1 survives at the National Railway Museum in York, the only one left out of 53. 0440 Double Fairlie. Imagine bolting 2 steam locomotives back-to-back, removing the tenders, putting a single crew cab in the middle, and giving each end its own boiler, smoke box, and chimney. That is a double Fairlie. Robert Francis Fairlie patented the concept in 1864, and in 1869, George England and Company built the first successful one, named Little Wonder, for the Festiniog Railway in North Wales. The Festiniog ran on a gauge of just 1 foot, 11.5 inches, hauling slate down from mountain quarries on curves so tight that conventional locomotives struggled. Little Wonder weighed under 20 tons, but could haul 100 loaded wagons up the incline. The secret was that every wheel was a driving wheel, maximizing adhesion, while both powered bogies could pivot independently through curves that would derail a rigid frame engine. The crew worked between 2 fireboxes, driver on one side, fireman on the other, and the locomotive ran equally well in either direction without needing a turntable. 49 enormous 0660 double Fairlies, weighing about 125 tons each, were later imported by Mexico's Ferrocarril Mexicano for mountain service between Mexico City and Veracruz. The Festiniog still operates double Fairlies today. Few other locomotive concepts from 1864 can claim that kind of staying power. 0660 Old Maude. No leading wheels, no trailing wheels, just 12 driving wheels and raw pulling force. Baltimore and Ohio Railroad, number 2400, nicknamed Old Maude after a famously stubborn cartoon mule, rolled out of the American Locomotive Company plant in May 1904 as the first standard gauge mallet articulated locomotive ever built in the United States. Designed jointly by the B&O's James Moolfield and Alco's Carl Mellon, Old Maude was a compound articulated engine with high-pressure cylinders of 20-inch bore feeding exhaust steam into low-pressure cylinders of 32-inch bore, driving 56-inch wheels. She weighed 334,500 pounds and generated 71,500 pounds of tractive effort. Enormous for 1904. Top speed was just 21 miles per hour, but speed was irrelevant. Her job was pushing heavy coal trains over the steep grades of western Pennsylvania, and she did it brilliantly. The absence of any guiding wheels made her unsuitable for fast running or sharp curves, but on the steep, straight helper districts of the Alleghenies, she was in her element. Old Maude proved the mallet concept in America so convincingly that within a decade, nearly every major railroad had ordered its own articulateds. 4444 PRR T1 Duplex. The T1 may have been the fastest steam locomotive ever built, and the most controversial. Baldwin and the Pennsylvania Railroad produced 2 prototypes in 1942 and 50 production units in 1945 and 1946, making it the largest class of duplex drive locomotives ever built. The concept split 8 driving wheels into 2 groups of 4, each driven by its own pair of 19.75-inch cylinders, all on a single rigid frame. Drivers were 80 inches. Boiler pressure was 300 pounds per square inch. Tractive effort was 64,100 pounds. Total engine weight was 502,200 pounds, stretched over 122 feet. Raymond Loewy styled the exterior in Brunswick green with a distinctive chisel nose. The T1 was designed to haul 1,000-ton passenger trains at 100 miles per hour, and multiple sources report it did exactly that. But the T1's chronic flaw was wheel slip. With only 4 wheels per driving set bearing less adhesion than a conventional 8-coupled engine, the drivers could break loose without warning at speed, damaging rods and pins. The poppet valve gear was maintenance intensive. Engineers not trained on duplexes made the slipping worse with heavy throttle. By 1948, the PRR had committed to diesel, and every T1 was scrapped by 1956. 414-4 AA20-1. 14-coupled driving wheels on a single rigid frame. No one had ever tried it before. Soviet engineers designed the AA20-1 in the early 1930s after visiting the United States and studying Union Pacific's 412-2 locomotives. They decided to go 2 axles further. Krupp, in Essen, Germany, began construction, and the unfinished locomotive was shipped to the Voroshilovgrad factory in Ukraine, where a 4-wheel leading truck was added to create the final 414-4 arrangement. The completed engine weighed 454,152 pounds, carried 240 pounds per square inch boiler pressure, had cylinders of 29 by 32 inches, 63-inch drivers spaced 5 feet 7 inches apart, and stretched 110 feet 8 inches long. Tractive effort was 70,548 pounds. The main connecting rod reached back to the 4th driving axle, and that was only the middle of the set. To negotiate curves, the flanges were removed from the 3rd, 4th, and 5th driving wheels. It made one publicity trip to Moscow in January 1935 and immediately revealed its fatal flaws. The rigid wheelbase bent the track outward, destroyed switches, could not fit on turntables, and broke couplers with its sheer mass. The more conventional FD Class 210-2 could match its pulling power at a fraction of the cost and complexity. The AA201 was stored at the Szczerbinka test facility and scrapped in 1960 without ever entering regular service. 4644 PRR Q1 Duplex. The Q1 was the Pennsylvania Railroad's most asymmetric locomotive and one of the strangest freight engines ever conceived. Built at the Juniata shops in Altoona in 1942, number 6130 was a duplex drive machine with 2 separate sets of cylinders on a single rigid frame. The front pair measured 23 by 28 inches and drove 6 coupled wheels. The rear pair measured 19.5 by 26 inches and drove 4 coupled wheels, but they were mounted backward under the cab with the connecting rods pushing forward instead of pulling. This reversed arrangement was unique in American railroading. Drivers were 77 inches, unusually tall for freight service. Boiler pressure was 300 pounds per square inch. Tractive effort reached 81,794 pounds. Total weight came in at 593,500 pounds over nearly 123 feet. And the whole machine was wrapped in Raymond Loewy streamlining. On paper, it looked powerful. In practice, the unequal cylinder sizes created uneven power distribution, and the engine slipped constantly. It was also far too long for most roundhouses and too rigid for tight curves. 686 PRR S2 Steam Turbine. The S2 had no cylinders, no pistons, no main rods. It was powered by a Westinghouse naval steam turbine spinning at up to 9,000 revolutions per minute and geared down to the driving wheels at a fixed ratio of 18.5 to 1. The same kind of propulsion that drove battleships and destroyers. Baldwin built the sole example, number 6200, in September 1944 for the Pennsylvania Railroad. It was supposed to be a 484, but wartime restrictions on lightweight alloys made it so heavy that 6-wheel leading and trailing trucks were required, creating the only 686-wheel arrangement in the history of railroading. The turbine produced 6,900 horsepower with a mechanical efficiency of 97%. Starting tractive effort was 70,500 pounds. engine weight was 589,920 pounds, and total weight with tender hit 1,032,100 pounds, over 500,000 tons. Drivers were just 68 inches, smaller than most passenger engines, because the turbine eliminated the reciprocating parts that limited wheel speed. At speed, it was economical and smooth. Below 30 miles per hour, it was a disaster. The fixed gear ratio meant the turbine was wildly inefficient at low speed, consuming enormous amounts of steam and sometimes dropping boiler pressure from 310 pounds per square inch to 85. In August 1949, the turbine suffered severe damage. The S2 was stored, then scrapped in 1953. The 6/8-6-wheel arrangement died with it. Thanks so much for watching. If you enjoyed it, smash that like button, share it around, and I'll catch you in the next one.